This is for Year 12 methods. It comes out of the NEAP 2017 exam 2 question number 5. So state the largest value of k for which the function, so k is the upper part of the domain. So here I've taken this, I've graphed it, and I've found that the turning point is at -1. So -1, -4 is the turning point. Therefore, k must equal -1, because to have an inverse it must be 1 to 1. So k equals -1. The rule for the inverse, put it on the calculator and solved for, and gave me that. I took the negative square root because this here's domain is negative. Therefore, the range would then have to be negative, so I'll need the negative square root for the range to be negative. State the domain and range. Well, it's going to be the range and domain of my original, so I'll swap them over. Find the coordinates of the intersection points of the curve, so I set them equal to each other. And when I set them equal to each other, I get two answers, -√7, and that gave me, when I was to analysis sketch inverse, I can see that I get two answers, but I only want this answer over here, because this answer over here is for the part of the parabola that's on the left. This over here is for the rest of the parabola, so I want this one here. So √7, -√7, -√7 is the intersection point. And in part C, I'm now going to move H to the left or to the right depending upon B. And I get a rule for g of x by substituting x plus b where x was, and I get a rule for the inverse doing the same thing. Part D. Find the values of b for which the graphs of g of x and the inverse have an intersection point at the origin. So if I set them equal to x and solve for b, and then make x equal to 0, I get this answer. So there's my f of b. Here is the inverse, and I took the negative square root. I've set it equal to the inverse equal to x, solve for b, I get b, set x equal to 0, and that gives me this answer, so there's my answer. Okay, now I'm down to E. Find the values of b for which the graph of g of x and the inverse have no intersection points. Okay. At the moment, I've got my parabola, and I have my inverse, and I'm getting an intersection point. If I move my blue curve to the left, then my red curve will move down. Because if I change B, that gives me a sideways translation, but if I change B, that makes it go up or down. So one's moving it sideways and one's moving it up or down. And what I'd actually like to occur is when that is my parabola, and this is my inverse, that's when there'll be exactly one intersection point. And then what I'm wanting is, when this is my parabola and then this is my inverse, so I'm wanting to know when it's not. Now, for this to occur, then the turning point and the starting point of my square root, the x and the y have to be the same, because it'll be on the line y equals x. So this will always be at -4. Therefore this will always have to be negative 4. So if minus 1 minus b equals negative 4, b's got to equal 3. And if I was to look at the same thing here, it's too hard because there's an x involved as well. But this b has to equal all of these. And okay, one thing that you can do, and it might be a little bit messy, but it might be worth it. If I go into menu, graphs and tables, I've put my original in terms of b, and this is the inverse in terms of b. And I'm going to tick them. And there's b's involved. Normally you can't graph them because there's b's involved. But if you tick the family of curves, so if I go, that was drawn from a previous one, if I go cancel, if I edit, clear all, okay, it clears my graphs. If I go graph, it won't draw anything because I've got a b involved. But if I choose this button here, it draws it for different values of b. So if I go zoom, memory, standard, okay. And I get a slider. So and that's when b is 4, there's no intersection. When b is 5, there's no intersection. When b is 6, there's no intersection. When I come back here, b equals 3, there's one intersection point. I'm going to ignore what's over here. I'm only going to look at what's on the left. When b is 2, I get an intersection point. 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. So b equals 3 when I have exactly one intersection point. So b has to be bigger than 3. Okay, so this interactive component of graphs and tables enables you. Now it worked because I had a whole number. I can't set these up that b increments by smaller than these whole numbers, I don't think. Let's just check the settings. I can. The step could be 0.1 if I wanted to. .1, 4.2, 4.3. So yeah, I can actually step it in small little increments as well. So that's a really cool little tool. Let's say you also had another variable. So if I click on this, I then get A and B. That's okay. So that's showing it this way, but it's also showing it that these intersection points have to be exactly the same, and that this will always be -4. So what's the value of V that makes that -4?